In this video, we're going to begin the process of then starting backwards from what we did last chapter. So we're talking about a word called factors, and I think you guys have heard this word before. This we sometimes call the GCF, and that stands for greatest common factor. So greatest meaning largest, common meaning two things that they haven't that are the same, and factor is this word we're going to talk about right now. So a factor is a number that's being multiplied to find a product. So in the last chapter, the problems that we were given when it was a multiplication problem may have looked like this. And because these are being multiplied, each one of these is a factor. So this is one factor, and this is one factor because they're being multiplied together. So because they're being multiplied to go into some number, a factor is something that can divide evenly in. So again, it's just going to be the largest number that can be divided evenly into two numbers. So here again, we're just looking for the numbers that can go evenly into both 12 and 30. Some of you can just see it. Others need to make a list. I like to sometimes just start with 1 and write out a list of all the factors. So I went from 1 to 2 to 3, and I'm just writing the ways we can multiply to 40. I would go to 4 next, but it's already right here on my list, so I know that this is my complete list of factors. And then I'm going to do the same thing with 30. So we have 1 times 30, 2 times 15, 3 times 10. 4 does not go in evenly, and 5 goes in 6 times. So this is my complete list of factors, and I'm just looking for the biggest one. That's what that G stands for. So if I start here on the right, I see that 6 is the biggest number in both lists. So 6 is the GCF. Okay. Sometimes our GCF is a variable. So again, we're just looking for what they have in common. So here we're going to look at 3. So we have just 1 and 3. And here we have 1 times 6, 2 times 3. Again, that 3 is the largest number on both lists. So 3 is my GCF. But I also need to take into consideration everything that's multiplied to get these. And so here we have x times x times x. That's what x to the third means. And then over here we have x times x. And you can see that the largest amount they both have in common is 2. So that is also part of my GCF. And kind of a quick rule of thumb, whatever the biggest, the smallest exponent is probably going to be your GCF, because we're looking for the most that they both have in common, and they both have at least 2. That's why this is that x squared. So I kind of just look for how many they both at least have. So in the second part of this video, we're talking about now how to divide out the GCF. So remember, a factor is something that goes in evenly, so we can divide it out. And we're just doing the process of FOILing backwards, and that's what we did last chapter. So here, when we look for a GCF, there is no number that these both have in common. Again, you can write your list out, and you can see that the only number they both have in common is 1. And 1 doesn't count because it goes into everything. So in this case, our GCF is only going to be a variable. And here we can see that the most that they both have in common is 1x. And again, if it helps, you can write your list out. So here we have x times x. Here we only have 1. And so the most amount that they have in common is just 1. So that's what I'm going to factor out. And when I say factor out, that means to divide it out. So x is my GCF. And when I divide it out, because I'm dividing, my answer now looks like a multiplication problem. Okay? We can kind of use the idea of numbers to do this. If I take 12 and I divide by 3, my answer is then multiplied by 3. So when I take 12 divided by 3, my answer is 4. And so I write whatever I divided out and whatever I got in my answer as now a multiplication problem. And we know that 12 is really equal to 3 times 4. So we're doing the same thing here. It's just now we have binomials, we have variables. So when I divide, here my 4 drops down. Remember, when we divide, we subtract those exponents. So I now have x to the first. Out here, these x's will cancel, and I'm left with minus 3. And all I did is I took a binomial, and I split it back up into a multiplication problem. And so we can always check our answer by using the distributive property if you want to check that answer. Okay. The next example over here, My GCF, hopefully we can see by now that 5 is the largest number that goes into all of these, and they all three terms have at least one y in common. So I'm dividing that out. I'm dividing each one of these by whatever I determine this GCF to be. And then my answer goes in parentheses. So for this first term, 10 divided by 5 is 2. And remember, we subtract those exponents. The next term, I'm going to get 4, and I'm going to get y to the first. And finally here, when I take a number and divide it by itself, I do get 1. Okay? Again, when you're done, it should look like something that could be distributed. It should look like a multiplication problem. Okay, so again, here in part C, we actually have no GCF. There's nothing that goes into each term, so this guy is already completely factored. And again, when we say factor, we mean use division to break it down into pieces. Okay? This next one looks a little bit more complicated because this is actually a subtraction problem, even though it's got, like, some of these factors are binomials. So what we still want to do is we want to look outside the parentheses for our addition and subtraction, and we see that this and this are terms. So this is actually one big old binomial, and we want to know what each term has in common. Well, I notice that they both have that x minus 3 in common. So in this case, our GCF is actually a binomial. And so that's what I'm going to factor out. So this one's going to look a lot more complicated, but it's the same process. So I still put that GCF in the front, and I always divide. Remember, we're dividing out the GCF, okay? My answer still goes in parentheses. So anything goes into itself once, so that whole thing cancels, and I'm left with 7. Over here, it's the same idea, but I'm left with minus 2x. And again, we could always check that answer using FOIL. If we think of this as one big number and distribute it, we would get 7 minus x, or sorry, times x to the minus 3. If I distribute that whole entire thing over here to this minus 2x, I'm going to get negative 2x times x minus 3. And finally, now we can factor by grouping. So sometimes when we look at a problem, we don't have a GCF. So since we don't have a GCF here, I'm going to put them into smaller groups to see if I can find a GCF in a smaller group, okay? And so here now I have 3 a squareds in common, and that's what I'm going to divide by. Again, it's got to be something that can divide evenly into each term, or else we're going to get a fraction. So 12 divided by 3 is 4. And again, we're going to subtract these exponents, and we get a to the first power. And these cancel, and I'm left with minus 3. Finally, on the right-hand side, here we have a GCF of 5. So I'm going to factor out a 5. And then when I divide it out, my answer then goes in parentheses. And a lot of times we think we're done here, but remember, this is still a binomial. And when we're factoring, we're trying to look for any common factor that we can divide out. So anytime we see this addition, we need to make sure that there's nothing in common on the left and the right. And so in this case, hopefully, we're starting to see that both of these underlined blue terms have 4a minus 3. So that's what I'm now going to factor out. So if I factor out this 4a minus 3, remember my answer is going to go over here. So this is kind of where I put my answer. And when I factor it out, I divide each of my original terms by whatever I'm factoring out. Okay? And we can divide because this whole yellow term is being multiplied. And division cancels with multiplication. So that's why those are allowed to cancel. And the same thing here. And so I'm left with 3a squared and then plus 5. And again, we could now FOIL this to get way back up here to that original problem.